Data cleaning. What exactly it means? As I mentioned earlier, client will send some data or we fetch data from some table or different resources, right? We cannot expect that all the time we get a proper data. Data will be messy. Every second, billions of data is getting generated. Every second. So you cannot expect all the data is in proper format. Everything is a cleaned one. So if everything is clean, if everything is proper, so then definitely no companies want data scientists. Because of the data is messy, they want someone to clean it and make it a proper format, or I would say convert into structured data. So in order to convert into structured, or I would say unstructured to structured data, so we need to apply some cleaning techniques. Cleaning can be anything, removing unwanted data, filling up the NANs, like a date we have seen. So we have to convert into proper format. So there are various reasons or various types of data we get. So we need to keep them in a proper format, or I would say in a structured manner. So for that, yes, we have to look into data cleaning part, which is one of the important phase in a data scientist life cycle. So that part we are going to cover here. Data cleaning. So let's import pandas and numpy. So here I am just giving 1 comma np.nan 718, some numbers, right? Some numbers. I'm converting into an array, usual method. So now let's try to understand some basics of NAN here. Will I be able to add any number to NAN? Because in any data, CSV file, so if we want to suppose say unit 1 marks and unit 2 marks, and this is the total marks. Let's assume this one. So a student attended first unit and second unit he did not attend it. So it is going to be NAN. So but I wanted to have a total marks, right? So then unit 1 plus unit 2, will I be able to do that? Right? So 20 plus NAN. So ideally I'm expecting 20 here, but if I try to add unit 1 plus unit 2, what is going to happen? Will it work or no? So that is what I was trying to understand here. So np.nan, I'm adding some number. So if I do that, it is not going to add. It is not going to add. Same thing goes for any kind of operation. Multiplication, addition, subtraction, division, whatever you want to do. With NAN, it is not going to give you any result. But in that case, how do I do the calculation? So I want total marks, right? So I cannot say student did not appear for both the tests, right? So yes, we need to have some kind of a technique. So with that, we will be able to add the numbers which are available. Numbers which are available. So we'll forget this. So yes, we have numpy np.nansum nan sum numpy.nansum. So this function will help us to add all the data. So in that case, how this is going to treat NAN? So it will ignore NANs. It is going to ignore NANs. So you can see this val1. So I'm going to use this here. So yes, I'm going to use numpy.nansum. So what it did, basically 1 plus 7 plus 1 plus 8. It ignored this NAN. 8, 9, 16, and this one is 17. So you can see that 17. Right? So that's how you can use this nansum. So you'll be able to add a data which have NANs and numbers. It will ignore the NANs. What is that? np.nan sum. All right. Let's look into some other. So here basically whenever you want to generate NANs, either you can use np.nan or you can say NONE. That also create a NAN values. It's not exactly values, NANs only. Right? So just for information. Now let's look into how to operate on these null values. Yes, we have seen, we have filled some NANs and all, but is that NAN is the only thing that we use only for a filling or things like that? So there are different functions available, different methods available in pandas, where we can work on the NANs, like how many null values present and how to drop, how to fill. Most of them we know, but specifically if I want to talk about null values, so one of them we always use, is null. Is null. Why we use is null? So this method is basically we use to generate a Boolean mask indicating missing values. Suppose I am checking marks. Marks dot is null. So I'm checking here whether marks has a null value or not. So it is going to give you either a true or a false. So these are basically what? Boolean expressions. So it is going to give either a true or a false depending upon whether it has a null or not. I'm asking, is it null? If it is, yes, true. If it is not, it is going to return false. That is basically what is null. Then not null. Not null. So it's just opposite of is null. Opposite of is null. That's all. So the result will be the opposite. Wherever in the earlier case, if it was throwing you true, it will throw you false, right? And this one will return you true because it's a opposite of is null. Then we know what is drop any. We have worked on that, and we also know what is fill in. So these are four methods we always keep in mind when it comes to null. First, I'm going to check it. Either you can check through is null or not null. You want to drop it, you can drop it. You want to fill with some other data, you can use a fill in. So nothing else we can do other than these four functions, right? Okay, so we'll see one by one. We have seen already, but we'll try to deal with some different way, right? So using some different techniques. Because our topic is data cleaning. We will see how to clean the data. Now let's look into it. So here I have generated a data frame, right? So I'm not going to go through this dictionary. It is a self-explanatory. So I'm just going to create one dictionary, take this dictionary, and I'm going to use the column names, and the whole thing I'm going to convert into data frame. And this is how it looks like. Create. So I have created a data frame. So now this is basically students' marks and some details, first name, last name, age, sex, unit 1 and unit 2 marks. Some of the data is missing here. Some of the rows are having entirely NANs. So how do I clean it? What and all I can do with this? Let's look into this. So if I want to drop an entire row, right, or entire column, depending upon the NAN, we have seen some different techniques. So here I'm going to say df.drop_NAN. What is going to happen here? So it is going to delete wherever there are NANs, it is going to delete all those values. So NAN and NAN by default row wise. How many rows left? 0, 3, 4 and 5. 0, 3, 4, 5. So it looks for NaNs. Wherever NaN present, that entire row will be dropped. That is basically what drop Na. All right, pretty straightforward. We have discussed this earlier as well. And we also discussed if I want to drop column wise, I will change axis equal to 1. Now, so let's print our original data frame because we have not saved, right? We did not say in place equal to true. So it will retain the original data only. Now I'm saying how equal to R. How equal to R. df.drop in same method. Here I'm giving a new parameter, that is how equal to R. What it is going to do? Rows that has all NaNs will be removed. Because see, there is no first name, last name, neither age, sex, unit 1 or unit 2. It means that student did not appear for the exam. Or student does not exist. So in that case, there is no point keeping this guy, right? So this unit 1 and unit 2, we can deal with it. Maybe some mistake or something like that. We'll deal it. But if I don't have any information, why do I need that? So that time I will say how equal to R. So it will delete the row which has all NaNs. All, that is what is R. Right? Simple concept. Now let's create a final score here. I have unit 1 and unit 2. I'm going to create a final score. So I want to add unit 1 and unit 2 and I want to keep this final score. So for that I'm creating a new column. Right now what we will do, we'll create a empty, NaN column, right? Later we'll deal with that. Because I wanted to show you something. Final score is having NaNs right now. So the reason why I have created, because I wanted to show you this how equal to all. So if I just leave it, so it is going to delete this one. But I'm saying axis equal to 1. So it means that the column wise, the column which has all NaNs. So only that column will be deleted. Right? So yes, axis equal to 1. This makes a lot of difference. Row and column wise, you can decide based on the axis. Now, yes, we know what is fill Na. I'm going to fill it with 0 value. Right? So let's execute this. And yes, we have all the zeros. Wherever we have NaNs, it got filled with the zeros. This also we know. Now let's print the original data frame. So now, yes, we have to fill the data which should make sense here. I cannot fill number here 0, right? I cannot fill number 0, 0 or 10. It doesn't make any sense. So I have to fill the proper data. So our main objective is to clean up somehow using some different techniques. Make unstructured data into structured data. Keep the data clean. For that, we can apply whatever the methods we know. But it should make sense. When I say final score, I have to add this unit 1 and unit 2, right? Then it makes sense, final score, or I would say total score. So what I'm going to do, so in order to do that, first of all, I need to fill these guys, correct? I need to fill these guys. Then we can add both unit 1 and unit 2 and fill this particular column. So right now we don't have a data here. Some of the rows are missing. So let's go ahead and fill that up. Let's take a unit 1 first. Data frame, unit 1. Yes, I have selected this particular column. In this column, I have a name. So you need to fill NA. Okay, I'm going to fill it, but what data? You need to understand here, even though you are filling some number here, it should make sense. Like say this unit test, unit 1 marks, right, out of 5. When it is out of 5, you have to fill the numbers or the marks below 5. You should not go greater than 5, right? But should I fill it a 0 or a 5 or 1 or a 2? If I take a 0, maybe that student is deserved to have 5. If I take a 5, if I fill with 5, maybe that student is not that intelligent. So it's a risky kind of a thing, right? So I have to keep the risk very minimum. So I don't want to take risk here by assuming something and filling that. So what I will do, I am going to take a mean of unit 1. How? Take this unit 1 column from the data frame, then I will say dot mean. Whenever I use a mean, it will fetch 4, 2 plus 3 plus 4 divided by how many elements? 1, 2, 3 and 4. That result data will be filled in the NAN. So I'm making it in place equal to true, right? So let's execute it. So this is the data we got, 3.25. So we have cleaned up this NAN in this particular unit 1. So it is not risky, right? Neither it is too low or too high. So it is in between. The risk is very minimum. So that is the idea. This is one of the way to fill the NANs. Again, you need to make sure it is whenever you are using a mean, it should be numeric. And you may ask, how do we fill the last name and first name? Let's see how we can do that, right? We'll work on that. Now, so here, this is one way. Let's see one more way. NAN and NAN. So what I'm going to do, I'm going to select this unit 2 dot fill NA, same concept. So this time I'm going to fill based on some group. Suppose say this is male and female, right? Here male marks are there 2, 4, 5, and female marks are like a 3, 4, 3, something like this. And here we have a NAN, right? We have NAN here. So here we don't know whether male or female. So we are not worrying about this. We are worrying about this. So if female data is missing, female marks is missing. So what I'm going to do, I wanted to fill the marks which other female students based on other female students marks. So first what I'm going to do, I'm going to say df dot group by sex unit 2. Means we have a male and female, you group them. So whenever I say dot group by sex, it is going to group male and female. Very simple. Then I'm selecting this column, unit 2. Unit 2, then I say dot transform. Transform what? Mean data. We have grouped male and female. Then I'm going to transform mean data. So only female data will be fetched. 3 plus 4 plus 3. In this case, let's take this data only. Okay, let me write the same data what we have here so that we can see the actual result. So female, we have a 4 and 4. 4 plus 4 divided by 2, which is nothing but 4 only, right? So let's check. Yes, 4 and 4. So take a female marks and take a mean of it and transform. Transform to this particular here, this NAN. So that is what I'm trying to do here, right? So you can see this data filled with a 4, right? Fine, but still we have some more NANs. Let's see how we can fill that up. So now let's say you wanted to select only those data which are not null, which are not null. Let's understand this not null. So here we are trying to understand different methods. So I'm saying from the data frame select age, which should be not null. Select this age. I don't want to see not null. Sorry, I don't want to see the null. And this is a and another condition. Along with this, any data the same row, if it has in this column, that is data frame, in this data frame, select the column sex, then I'm checking I want the data which is not null. So ideally, I want the result where age and sex in that column, in those column, I don't want any null values. Whichever don't have null values, you return that one. So that is the idea here. Let's execute. Now you can see that the first row did not have data. Both are in the same row. So we have not returned that particular row. Similarly, you can use different columns. It will look for that column. And suppose here you have a M. So in that case, it would have returned entire data frame because this condition is not matching. Here I'm saying and. Both the conditions should be true here. So this way you can ignore the NANs without writing any extra code. Depending upon the column, in which column you don't want to see NAN, so yes, you can give the column names. Let me repeat this. This is the whole data frame, okay? In that I'm writing this condition. Age not null and sex not null. Wherever you have NAN, in those columns, don't return. So yes, you can do that using this not null. Let's print our original. I have not saved or anything because we are trying to understand different techniques here. Now, let's understand backfill. Backfill. So what is backfill? So we know that dot fill NA value equal to some number we used to give. So whatever we used to give, so that data used to fill up. Now I don't want to give my own number here because here, yes, it will take a number, but here it won't take a number. Here it won't take number. So how I'm going to fill that? So yes, there are two things, B fill and F fill. What B fill will do? It is going to fill back. It's a backfill. It's a backfill. So if you see here, Tina, Ali, and 36. Backfill. So yes, we have a data in this second row. And in the first row we have a NANs. It backfilled, 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 backfilled. Wherever we have NAN. So it will take this data, the next row data, and fill back. Same data it will be filled. That is basically backfill. Right? Then what does F fill do? Let's look into that. DF. So in the forward fill, F fill is nothing but forward fill. So what forward fill do? Yes, I hope many of you would have guessed it. Yes, it is going to take the previous data and fill it. It's a very intuitive. So anyway, we have a data here, right? So Jason, Miller, 42, M, and here 3. So this is forward fill. Take the previous row data and fill forward. So that is what the forward fill. So here I have converted or I would say saved this data frame by saying in place equal to true. Now, let's say final score. So you see this, we have cleaned this entire thing, we have cleaned using different techniques, and this guy is still left out. So what I'm going to do, I am going to take this data frame final score dot fill NA. So this fill NA will apply only to this column because I have selected this. Then I will say dot fill NA. So what I want here, I want the total score. Total score means what? Unit 1 plus unit 2. Idea is very simple. DF unit 1 selected plus DF unit 2. It is also selected. So take unit 1 and unit 2 marks and place it in final score. And I'm just saying in place equal to true so that I can save this data permanently. Now our data is updated. Four plus 3, 3.25 plus 3, yeah, and so forth. You see how we have where we were actually. So okay, let's finish this. Then we'll go back and see our original data set. So now I have an entire thing. So I wanted to add the location of the students, or I would say the school. So all students belongs to Bangalore school. So I'm going to create a new column and I will just give Bangalore, right? So if you want to give different, yes, it's up to you. So for each and every row, it is filled with a Bangalore. Now this data set looks pretty clean. Now let's go back here. Where is that original? Yeah, you see this was our original data set, right? We have worked on different techniques and we are able to make it a proper data set, or I would say clean data set. Now I can start analyzing depending upon the requirement. So this is one of few techniques that we can use to clean up our data, right? All right. Next is hierarchical indexing. So let's create a data frame. This is our data frame, right? Let's not look into this huge, data here on numbers, some text. So irrespective of how it is, so final data frame looks like this. So in this data set, in this data frame, we have a company, we have a project, in charge, sales in millions, profit, right? Google company is there, and there are have a project 1 and their respective, so Sundar Pichai, Roth, these are basically in charge of a respective company. These are the real guys, okay? So Sundar Pichai we know, and Roth, Kevin, I believe. So Benjamin, Surgery. So first names, what we see here. So he is the leading the first project, and Roth is vice president. Not exact. I'm not sure exactly vice president, or I think the CFO, I believe. So they are leading this, and their sales are 54 million, and in that 54 million, 14 million is the profit. So this is the sale, and these are the profit numbers. Now, why are we discussing this? Here, I don't want a project, right? I don't want to see the names. All I'm interested in the sales and profit and the company. Here, Google is mentioned 4 times. FB mentioned 4 times. Amazon mentioned 4 times. Because each company will have different department, many projects. So irrespective of a project or the in charge, end of it, what we see? what we are interested in number of sales or the profit. So let's see how we can interpret this kind of a data set. So what I'm going to do, I don't want to see Amazon like FB. I want it in a simple format, easy to understand. So what I will do, I will say data frame, this is our data frame, dot set underscore index. Set underscore index. So I'm saying company, comma, project. This is the company and this is the project. So I'm going to keep these guys as an index. I will talk about this. Let's first execute. Now you can see I have taken the company and project. I have converted that into index. How? Set underscore index. So what it means that you can take any column in your data set and you can set that as an index. As the name indicates, set index, and you have to give the column names which you want to set it as a index. And what is this drop equal to false? So when you are setting this as a index, why do you want this again? You want to keep? If you want to keep, say drop equal to false. If you don't want to keep this, so then what you can do, you can just say, you can just remove this. By default, it is going to be, I'm going to execute this. By default, it will be removed, right? So that is basically what drop equal to false. So now it looks clear. It looks better than this. Okay. So yes, the same thing actually. So this is how it looks like. And when I keep in place equal to true, so it looks good. Fine. Now, if you want to swap the level, like a company and a project, you can just say df.swap level. So project will come this side. Basically, it is going to shift. So using your data frame dot swap level. The way how you want to look the data. Give the company and project. So company and project. So it is just going to interchange. So now we can see project first and company. Fine, this is all fine, interchange and things like that. Still our question remains same. I want to see total Google sale, total FB sale and Amazon sale as well as profit. So what I can do, I can take this whole data frame dot sum. So on which level? On company. Based on the company, yes, I want total sales of that particular company and the profit. Obviously, it is going to show you profit. So this is Google total sales and total profit. Similarly for Facebook and Amazon. So if you want to change it to project, okay, let's take this whole thing. Let's say project. So first project 180 sales, second project 173. Right? So that's how you will be able to get. So all the first project will be taken, all the first, and yes, it is going to give 180. But here it doesn't make any sense, right? Because first projects available in Facebook, Google, and Amazon. So how can we add different company sales? It doesn't make any sense, right? But still, if you're dealing with only one company, there are multiple projects displayed multiple times. So that time you can go ahead and use this kind of a methods.